Hey guys, so I hope you all have watched the previous video where I talked about how we will solve diagonalization problem when we have got a unique eigenvalue. In this video, we will be understanding how to solve diagonalization problem when the eigenvalues are same.
So starting with the next question, it is the matrix A diagonalizable or not? If it is diagonalizable, then we have to find both D and M. Now, your M we know was your transforming matrix, and we know that our D is the diagonal matrix. It's important for you all to actually remember what each symbol is representing, because there might be a possibility that the examiner is just giving you D and M and you don't know what is what. All right, so you need to be aware of it. All right, now let's get started. I have already solved and gotten the answer for lambda. Lambda comes out to be 2, 2 and 1. So as you can see, these are repeating, so that means we'll have to check if they are diagonalizable or not. In the earlier question, we saw that all of the answers are unique, right? The values are unique, so we said that matrix A is diagonalizable, right? So now that these are repeating, we'll have to solve them. Okay, so what I'm doing is I'll go ahead and I'll take for lambda equals 2. Characteristic matrix comes out to be 0, 3, 4, 0, 0, minus 1, 0, 0, minus 1, and again x1, x2, x3 equals 0, 0, 0. So now we all know we have solved these kinds of questions earlier as well, and I will be linking one such in the I button here. If you can see here, we have got two of these rows repeating themselves. So what we are going to do is we are going to be performing this operation r2 minus r3. So what happens is your r2 gets eliminated completely, so it becomes your final matrix becomes something like this. Actually, you add them. Do we add them? No, we subtract them. Just a second. All right, so we are subtracting them, and then this is what the final matrix looks like, right? So this is again going to be as it is. This is 0, 0, 0. So now we use the concept of GM and AM. So now what we're going to do is, we know that the this is one entirely zero row, so we say that number of non-zero rows is going to be 2. Now this is done. That means that the rank is also 2. Rank is equal to the number of non-zero rows, so rank is also equal to 2. Now we find n minus r. So your n is your number of unknowns, and your r we all know is rank. So number of unknowns are 3, x1, x2 and x3. So 3 minus 2 gives us a 1. All right, and this will become your GM. Now we're talking about AM. So AM is basically how many times the eigenvalue is getting repeated. So here we had this lambda equals 2 comma 2 comma 1. So your 2 is getting repeated twice, right? We can write it, it's getting repeated twice. So that means the value of AM would be equal to 2, right? So we say that GM is equal to 1 and AM is equal to 2, which means that our GM and AM are not equal. Because of this condition, we say that the given matrix is not diagonalizable. If AM and GM are equal, then we say that they are diagonalizable. But because AM and GM are not equal, this is not diagonalizable. If you get this question in the exam, and if this is for 5 marks, you solve and show how you got the value of lambda, and then you write just this much with, again here you have to write the characteristic matrix is and then the standard form, and you write it as it is, as I have shown here. That is it. You might as well, because it is for 5 marks, you might as well have to show how you get the vector for lambda equals 1. But that is it. That is all there is if a matrix comes out to be non-diagonalizable. So we have covered all of the concepts of diagonalization. We saw one question where we had unique eigenvalues, and we found that we found their diagonal matrix as well as the transforming matrix. And right now we did one example where we had repeating eigenvalues, and because of the circumstances, that is, we got AM not equal to GM, because of which the matrix becomes undiagonalizable. Okay, one more thing, it is not necessary that if you have repeating eigenvalues, the matrix is not going to be diagonalizable. That is not true. If your AM and GM becomes equal, then that matrix is diagonalizable. Once you say that the matrix is diagonalizable, then you have to follow the same thing. You just need to use either Kramer's rule or however whatsoever is happening, and according to that you will find the value of x1, x2, x3, and you will get your vector. Once you've gotten the vector, if they are asking you to write the transforming matrix, you do that, or else it's okay if you don't. So that is it.
So this was the last concept in the chapter of linear algebra. So I hope you all found this video helpful. So this series is finally completed. The first chapter for second year mathematics is finally done. If you all have any doubt in any of the concepts, don't forget to write it down in the comment section, and I would be very happy to answer. Thank you so much. Bye bye.